can be turned on or off, ignored, or paid attention to based on this mask. You can get into some wild configurations. Just take care that you don't do that often, because it's an administrative nightmare if you do. So use your access list wisely. In some cases, you might have to do something like this. And if you do, administer that access list on your own, because as soon as somebody else comes in and takes a look at it, there's a great chance that they're going to get confused and make a mistake. All right, let's go on to our next topic. We just got through covering ACL filtering, probably the most important part in this section of the ACL Essentials. Next, we're going to go into ACL processing. All right. The big question here is this. In reading an ACL, there's two choices. Well, with any list that you're ever going to run into in computers, it's either processed by first hit or best fit. Now, in the case of an access list, it's first hit. This is the answer, and we're going to illustrate how that happens and why it's important. Here we go. I have three different access lists here, 1, 2, and 3. We're going to pay attention just to the first one for our first example. Here we go. Access-list 99. This time we're going to deny. So understand we're denying a host. Remember our key words and looking at this command and the filtering. If you have a host, it's really the equivalent of writing out 192.168.1.1 as an IP address, and then the mask 0.0.0.0. They save you a little bit of writing by allowing you to put down the keyword host. And it just makes more sense too as you're reading these access lists. The next line, access-list 99 permit anybody, which again is a shortcut for 255.255.255.255. Okay, this is our access list. I am trying to run a packet through an access list with the source IP of 192.168.1.1. Let's see what happens. I go to the first line. All access control lists are read sequentially from top to bottom. And remember, we're going to hit first hit. So the first hit says, I want to deny anything with the IP address 192.168.1.1. Is that what I have? It'll run through the example we just ran through, and the computer will say, I have a match. That packet is denied. Excellent. My information is safe. That's what I wanted. I don't even hit the second entry because I've matched on the first. But if I had any other IP address as a source IP coming through, like 192.168.1. Let's say this changed to 2, then it would go to the access list, not match on the first one. It would have to go to the second line where the match is any, so of course I match, and it does exactly what's said within the line, and it'll permit that traffic. So this ACL essentially denies one address, allows everybody else. All right, let's move to our second example. I'm going to use the same source IP that I used here, 192.168.1.1, the original, on this access list. But let's read the access list first. Access-list 99 permit 192.168.1.0. The mask is 0.0.0.255, which means to us I have to match the first three octets. The last octet is any number from 0 to 255. Then my next line in this access list 99 says deny a host. So here it's exactly this line. And the third line is exactly the second. All we've done is add a line in the beginning. Now let's process that same packet coming through. Our goal is to deny any packet with this source IP address. Let's see if it happens. We hit the first entry. This is a permit statement. The mask says 192.168.1. Any number in the fourth octet. Does it match? Yeah, it does. 192.168.1.1 matches. I'm going to permit. I'll never get to the deny statement, and because of the order of these entries, I'm not accomplishing what I want to accomplish with this access control list. Pretty straightforward, right? We just want to illustrate first hit versus best fit. It doesn't run through this list and say, you know what? Here's this exact IP address here, so it must want to deny this. It doesn't do that. First hit. Let's go to our third example. If we had one line, access list 99, deny, host 192.168.1.1, which is the first line you see here, and that's it, let's see what would happen. Some of the logic behind doing this might be, okay, if I want to deny this address and let everybody else go through, why can't I do that in one line? And the answer is simple, but it's kind of hidden. There's an implied deny any at the end of every ACL. So if you write these with, in fact, we'll start with this one, an implied deny any as the last line. Let's process this. Anything coming in with a source IP as 192.168.1.1 will be denied by the first statement. That packet that we passed earlier, 192.168.1.2, we had a 2 here, will be denied as well. We won't permit any traffic at all. So it's important to remember that. So if we go back to our first example, this is the correct way to deny one IP address and deny everybody else, or permit everybody else, because this has an implied deny any that you just won't see at the end of the access list. Alright, very important. Keep that in mind. So that's how you read an access list. First hit. Let's move on. Applying an ACL to an interface. This is our next subject. Alright, the first thing we're going to have to do is understand what command is used to apply an ACL to an interface. And we find it here. The command is IP access -group, then a number, which is the number that we assigned in our access list. So the examples we worked on the previous whiteboard were 99. We could type in 99 here, and we're applying all those access list statements to this access group applied to an interface. And then we have a choice of whether that's applied in or out. So let's look at why that would be important. Let's pretend this box is our router. Our routing logic sits here in the center. Each interface, E1 and E0 in the case of this example, E standing for Ethernet 1 and Ethernet 0, have an option of traffic coming in or going out, and the same thing here, coming in or going out. We need to tell our access list which way it needs to be applied with the access group command, either coming in or going out. And that's the purpose of this statement. Understand that the default direction, if I didn't include either one of these words, if I just stopped at the number 99 and hit enter, the default for the direction is outbound. So here's the default here, and here's the default here. Let's move into the router and take a look at this actual command and how it's applied. Here we go. Actually, before we move on, we're going to move into the router, but one thing I did forget to mention is this IP access group command is a sub-command. Now, if you recall from our conversation that we had when we ran over iOS basics, two types of commands. One is a global command. This affects the whole router, the entire router, and then sub-commands that are beneath global commands. That's what this is. And the reason for that is, look at what we're doing, applying an ACL to an interface. So the first thing we have to do is use a global command to define an interface. So if we were in config T, I would type something like interface E for Ethernet 0. Now I'm in this interface here, and I can assign my ACL to that interface. Now we can move on to the router. Let me log in. First thing I'm going to do is a show IP interface brief. This is a command that's going to show you all the interfaces on your router. Very key command, and I would remember this and use it in your daily work. What we see on this specific router is we have Ethernet 0 as an interface, Serial 0, and Serial 1. Ethernet has an IP address assigned, and it's up and up. So everything's ready to go on that. Now let's type in a command that's going to show us our access list. This will show every access list on the box. We have one, access list 99. Okay? These are the lines here within access list 99 that is a standard IP access list. I know this looks kind of weird. I mean, this isn't the format that we put this in, right? So why does it show up there? Let me show you something. If we do a show configuration, what we're going to see is our access list here in the format that we originally put it in. So it does save it that way in the configuration file, but when you do a show access list command, just remember it comes out a little bit differently. Let's move into config T and make our changes. The first thing we're going to do is use the interface that we saw, interface E0. Now we are in a config interface subcommand. This is where we apply IP access group 99. Now, we're going to go to the magic question mark, and this is to illustrate what we had mentioned before. You can go in, you can assign it out, or you can simply hit return, and it's going to default to out. Right? So let's do that. It's an out. Once we've done that, let's get out of config T with a Control Z. Write this to mem, which is saving from our regular RAM to NVRAM. Once this is completed, we're going to do a show config again and see that on our interface this is assigned now. Alright, let's look at E1, or I'm sorry, E0.